Hello, humans. So you have come super far in this section. Good job. I'm proud of you. Good for working so hard. Um, we're gonna do some, I think they're fun. A couple of practice problems, and then the guided note sheet that have these in have some problems that are similar. Um, to both of these two problems, but these are going to be your examples so that you can get the practice so that you can pass the mastery check. So what are we doing? We're using two examples to practice finding measures of bisected angles and segments. What is a bisected angle? Tell me. I know you just said an angle that is cut in half to two equal parts. So here's your example of a bisected angle. And we're going to use this image to answer the question. So if ray KC, right here, why is it a ray? It's a ray because it has one point and then it goes on forever. That's why it's a ray. Is a bisector of angle JKL. Here, let's highlight that too. Oh my goodness. What is the measure of angle JKL? We'll do that in blue too. I was all excited that I was going to get to highlight something. So what do we know is the first thing, right? What do we know about these two angles? We know that they're equal, right? So we know that 2x plus 9 is equal to 3x minus 17. The reason we know that is because KC bisects the angles. So we're going to take, look at that. It only moved just a little bit. Okay, so we're going to take this, and because we know that they're equal, we're going to take 2x plus 9, and we're going to set it equal to 3x minus 17. Okay, and now we're going to solve for x, which is the same thing that we've been doing. So we're going to subtract 2x from both sides so that we can cancel this out. The reason why we're using the 2x is because then we're going to end up with a positive x on the other side. And so that's just going to make it easier by eliminating the need for negatives. So we have 9 equals x minus 17. Now we still need to isolate that x, right? So we're going to add 17 to both sides. Because why? That's right, we're doing the opposite operation so that we can balance the equation. So now we have, what's 9 plus 17? Oh, we're losing the title. That's okay. What's 9 plus 17? 26. So 26 is equal to x. Boom. So that was actually pretty simple, right? We have 26 equal to x. So this is where like the kind of complicated part comes in. Are you ready for it? The complicated part is, now that you have x, you have to substitute in, here, we'll go up here. You've got to substitute in. So you've got 2x plus 9 plus, let's put parentheses around that, just because it's good practice. There are no negatives that need to be distributed, so it's not necessarily going to make a difference for our math, but it's still good practice to put parentheses around. See, and then every time I move things, it just moves the things over. We're going to move that over so that I can do it a little bit better, easier. And then we're going to set that equal to angle JKL. All right? All right, so now we're going to substitute in our answer, which was 26. So we don't need the parentheses anymore because we don't have to distribute anything to the parentheses because we're adding two things together. So see how I'm just substituting in the 26 for the x? Equals angle JKL. So 2 times 26 is 52 plus 9 plus, 3 times 26 is 60. 3 times 6 is 18, is 78 minus 17. I'm going to get out my handy dandy calculator rather than doing this in my head. So we've got 52 plus 9 plus 78 minus 17 equals 122. So now we know that the measure of the angle is 122. Remember, you're labeling 122 degrees. Oh, that was silly. Angle JKL equals 122 degrees. Okay, so we're going to go ahead and do the next problem really quickly because we're getting, it's getting long, but I don't want to make this 2 videos. So the measure of M is a bisector of segment AB. What is the measure of segment AB? So we're going to do the same thing pretty much that we did last time. We're going to take our 2 measures, right? We have x plus 5. Oops. We have x plus 5 and we have x minus 3. And those are the measures of our line segments, and we're going to set them equal to each other. So we have x plus 5 is equal to 3x minus 3. So now we're going to solve for x, and we're going to go ahead and do the same actions at one time. The reason that I'm subtracting the smaller x is because then I'll have a positive 2, and the reason that I'm adding the negative number, or I'm adding to the subtracted number, is because then I'll have a positive number. So that means I'm going to end up with like super great. Totally should have written those in black. That's all right. Now I'm going to divide by 2. So I'm going to end up with a really clean number. I did this on purpose for you. And we're going to cancel those 2's out, and then we're going to reduce our 8 to 4 is equal to x. And now we're going to do the same thing. We're just going to substitute back in. So now we know that x plus 5 is, x plus 5 plus 3x minus 3 is equal to segment AB. And we're going to substitute in our 4's. So we have 4 and 4 plus 5 plus, there we go. So we've got 4 plus 5 plus 12, because 3 times 4 is 12, minus 3 is equal to line segment AB. So 9 plus 12 is 21, minus 3 is 18. So line segment AB is equal to 18. Oh my goodness. I'm so happy that we finished that. So now try the practice problems. Remember, pause and go back and do whatever you need to do to review this. Write it down however it works for you. Let me know if you have any questions.